The question that was proposed yesterday was which shape slide minimizes time? Remember, time, not the distance. So answer to that question is curve 3. From point A to point B, a particle reaches from point A to point B. It will take the least amount of time when it chooses the path number 3 or curve number 3. We are going to know how this happens and what was the history of the problem. This problem was first hypothesized by Galileo, and later on it was rediscovered by Johann Bernoulli, who was the brother of famous physicist and mathematician of that time, Jacob Bernoulli. The answer that Galileo proposed was that it will be a circular curve, and while in our solution it looks like a circular curve, but it was not a correct solution. So he wanted to challenge all the popular mathematician of the world, and he wanted to know that who is going to solve this. You can see he addressed this problem like Johann Bernoulli addressed the most brilliant mathematician in the world. By the time Newton was a veteran, so he was kind of like retired from all these physics and mathematics problems, but still he was intrigued. He was annoyed that, oh, how dare someone challenges me, I'm the superior of among them all. But still he worked day and night, and he was the first to solve this problem. Unfortunately, his solution was not correct. So it's okay if you didn't get it too, because the finest mathematician and physicist of that time, they were also not able to solve this problem correctly.
So it turns out that Bernoulli already had solution and just wanted to test other mathematicians how they test in his challenge. So his solution was actually inspired from Fermat's principle, which says like light always selects the fastest path, and if the light particle travel from point A to point B, which path will it take? That was the approach that Bernoulli took. This picture you might have already seen. Ray of light bending when the angle of incidence is changed. This is the principle of refraction of light.
You can see this via an animation, how the path changes when I change the angle of incidence.
We can picture the light taking the shape of this path. So this curvature is what light creates when we have multiple layers. The concept behind it is conservation of energy. So kinetic energy equal to potential energy, and here we see that velocity of a particle is directly proportional to the height of the particle or the distance traveled by it. So V1 is directly proportional to Y1, V2 is directly proportional to Y2, and V3 is directly proportional to Y3, and so on. So the name of that curve that is formed, which is not cyclic, looks like it but not cyclic, it is a cycloid actually. So the name of that curve is Brachistochrone. It's a Greek word which means shortest time. To understand the solution mathematically, you should go through the solution provided by Mark Levy. He's a renowned professor, a great mathematician, and in order to get further insight and better visualization, you should visit 3 Blue 1 Brown and Vsauce. So that was all. Thank you very much.